This is practice problem 21.3. The rule of 72 says that if you have an annual interest rate of R, then it will take about 72 divided by 100 times R years for your money to double. For part A, calculate the balance at the end of the predicted doubling time for $1,000 at the interest rate of 2% if it is compounded yearly, monthly, and continuously. So the first thing I need to do is find the predicted doubling time. I'm going to call that T, and T is equal to 72 divided by 100 times R. So R is my interest rate, which is 2%. So to change that to a decimal, I'm going to take my decimal point and move it 2 places to the left. So this is equal to 0.02 in decimal form. So that means that T is going to be equal to 72 divided by 100 times 0.02, which if I put that into my calculator is going to give me 36. So my predicted doubling time is 36 years. Now I want to calculate the balance after 36 years if my interest is compounded yearly, monthly, and continuously. So for those first two parts, remember the formula for compound interest is principal times 1 plus R over M to the power M times T. So if my interest is compounded yearly, I've still got my R is equal to 0.02. My principal is, what I start out with is $1,000. For yearly, the number of times that interest is compounded per year, M, is going to be equal to 1. And my T is equal to 36, so now I can plug that all in. I'm going to get my amount after 36 years for interest compounded yearly is going to be $1,000 times 1 plus 0.02 divided by 1 to the power of M, which is 1 times 36. And that is going to give me $2,039.89 after 36 years. So that's a little bit more than doubled, but very close. What about if my interest is compounded monthly? Then the only thing that's going to change is my value for M. So if my interest is compounded monthly, that is 12 times per year. So M is going to be equal to 12. Then A is going to be equal to 1,000 times 1 plus 0.02 divided by 12. And then my power here is going to be 12 times 36. So if I put that all in my calculator, I'm going to get $2,053.20 after 36 years. So a little bit more if it's compounded monthly, but still close to the double, which is $2,000. Finally, let's look at interest that is compounded continuously. And remember, the formula for interest compounded continuously is A is equal to the principal P times the number E to the power R times T. So this is going to be, my P is still the same, $1,000 times E. My R is 0.02 times 36. If I put that in my calculator, that is going to give me $2,054 and 43 cents. So these are all pretty close together and about double, so 36 years is about the doubling time for that. For part B, it says the actual doubling time for these is 35 years, 34.69 years, and 34.66 years, respectively. So a better name for this rule would be the rule of 69.3. Why do you think people prefer the rule of 72? Well, the doubling time is going to vary a little bit depending on the interest rate and the compounding period. Also, the rule of 72 is a lot easier to remember than 69.3. And as a rule of thumb, we saw that it's close enough to give us a good estimate of the doubling time, even if it isn't exact.